Okay, so what is a recurrence relation? Well, a recurrence, or a sequence, is just a list of numbers that is written down in succession. So a sequence can be any set of numbers, really. Like I could have 2, and then 5, and then -1, and then 7. That is a sequence. But in this case, there's no like hard and fast rule that's connecting all of those values together. When we use a rule, or when there's a pattern, this is called a rule-based sequence, and rule-based sequences can then be expressed by what's called a recurrence relation. All sequences have to have a starting value and then a rule that you follow to generate each of your terms. So if we're going to generate the first 5 terms, a sequence starting at the value of 2, and then using the rule double the number and subtract 3, our starting value is going to be 2. We're then going to double the number and subtract 3. So 2 times by 2 is 4, subtract 3 is 1. 2 times by 1 is 2, subtract 3 is -2. 2 times by -2 is -4, subtract 3 is -7, and then 2 times by -7 is -14, subtract 3 is going to be -17. So here we've got term 1, 2, 3, 4, and 5. Right. Now, a recurrence relation, rather than expressing our rule like the example above, a recurrence relation expresses that in terms of mathematical symbols and terminology instead. It tells us how each term is found based on whatever your previous term is. So there's always 2 parts to a recurrence relation. There's always going to be a starting value, and then there's a rule that links successive terms, so the previous term to the next term. Some of the symbols that we use to represent successive terms, so it's one term that comes after the other. Vn represents our current value, or current term. Vn plus 1 represents the next term. And then V0 represents our starting term, or starting value. And then N represents the number of iterations. Now that might be a word that you're not familiar with. Iterations just means the number of times that you're going to repeat it. So number of times something repeats. Number of times something repeats. So if we now find the first 5 terms of the sequence defined by t0 equals 6, t of n plus 1 equals 3 tn plus 5, t0 is our first term, tn plus 1 is the next term, and tn is our current term. So we're going to start with 6. To find tn plus 1, we're going to use the rule 3 times by our current term plus 5, which will give me 3 by 6 is 18, 19, 20, 21, 22, 23. So I might just, our current term, We're then going to go on to find the next term. So, well, actually, in this case, our n value is 0. So this would be t lots of 0 plus 1 will equal 3 lots of t0 plus 5. That's t1 equals 3 lots of 6 plus 5. That's where the substitution for n, the number of iterations, could be substituted in. But I find that students tend to find this explanation a little bit confusing. So if we just think about tn plus 1 being the next term and just using our previous term each time, it's much easier to then generate your sequence. So we're now going to find the next term. So t2 will equal 3 lots of, this is t1. t2 with 3 lots of t1, which is 23 plus 5, and 3 lots of, what was it? 23. 74. Alright, so if I still need to do 2 more terms, and this is starting to get a little bit tedious having to do it by hand. So we can actually get our calculator to generate these terms instead. So in our calculator, if we start with our first term, so in this case our first term was 6, and press enter, we can then generate the series by tell the calculator what we need to do in this rule. So we're multiplying by 3 and then adding 5. So I want to multiply by 3 and add 5 to my answer. So there's my second term, third, fourth, fifth. So that's 5 iterations. So now I can take those values. I don't have to work them out. So T3 is equal to 227. Ah, crappy. T4 is equal to 686. Now you can see here, even though I've got T4, I've actually got a total of 5 terms because we include T0 as part of our count. So we got 5 terms in total. Now, recurrence relations can be written in a whole bunch of different ways. They're not always just going to be Vn, Vn plus 1, and V0. The notation can change around. So in this example, we've got Tn and Tn minus 1. So in this example, Tn is equal to our current term, and Tn minus 1 represents our previous term rather than the next term. In the second example, rather than using T's, we've got S's. So we've got an S instead of T. Right, so you don't always have to use the same letters. And in our third example, this function has been rearranged. Alright, so that's our introduction to recurrence relations. It is just a rule that links one value to the next value using each previous value.